All right, picking up where we left off with our Chapter 10 videos, and we were talking about exceptions to the octet rule, and the concept that anything period 3 and lower can have more than 8 electrons. That results in the exception of the expanded octet. So let's take a look at an example of that, as well as an example of how to do an a Lewis drawing for an ion. Okay, so let's do a Lewis drawing for the chlorate ion, ClO3-. Okay, so the only thing that's special about this is that negative sign means that we add 1 electron to the valence total. Okay, if it were a 2-, I would add 2. If it were a 3-, I'd add 3, and so forth. Okay, if it's a positively charged ion, I subtract 1 from my total. So our chlorine has 7. Each oxygen has 6. And then we have 1 more for that negative charge. So we have 26 valence electrons. Okay, everything about drawing this structure is going to be the same steps. Okay, so I'm going to draw a skeletal structure that has the least electronegative atom in the middle, and that's chlorine. Okay, I'm going to subtract 2 electrons for each bond that I've drawn. So I drew 3 bonds, so 6 electrons in the bonds. So I have 20 left to put in my drawing. I'm going to fill the octets on my outside atoms. Okay, so that took up 18 electrons. So I have 2 left to put in my drawing, and those go on the central atom. So I have no more electrons to put in my drawing. All right, so let's take a look at formal charges. Well, first we're going to check octets and make sure that everyone has at least an octet. My oxygens, each of them has access to all these electrons, so 8. My chlorine also has access to 8, so everyone has at least an octet. Now let's check formal charges. Okay, so currently, each oxygen has 6 valence minus 7 in the box. So each oxygen is a -1. So -1, -1, -1. They're all the same, so they all have the same formal charge. Let's look at what the chlorine is doing right now. Right, chlorine has 7 valence, and there are currently 5 electrons in the box. So chlorine has a +2 charge. Right, so overall, 3 -1s and a +2 gives us an overall of -1, which is the charge of our ion. Okay, that's what we want. But our goal is to get the lowest formal charges possible. Okay, so right now my formal charges are -1, -1, -1, +2. Right, it would be better if I could find an arrangement where I have 0, 0, 0, -1. Okay, so my goal is to get a lower set of formal charges. So let's see what happens. Whoops. If I make some more bonds. Now, chlorine is in period 3, so it's allowed to have more than 8 electrons on the central atom. So I'm going to borrow from my outside atoms and make double bonds. Now, remembering, cannot touch these. Okay, it's a very common mistake for students to borrow from the central atom to make double bonds. You have to leave those alone. Okay, when making extra bonds, you can only borrow from the outside atoms. All right, so let's borrow from our left-hand oxygen and make another bond. And let's take a look at formal charges now. So if I draw my box, 6 minus 6, so that oxygen has a 0. Great, so that lowers my formal charge. Let's look at the chlorine now. So I have 7 minus 6, so a plus 1. Right, so currently my formal charges stand at 0, minus 1, minus 1, plus 1. Okay, it would be best if I can get to more zeros. So let's take a look. Since chlorine is allowed to violate the octet rule, as long as it has 8, we can keep putting more bonds. So I'm going to borrow from my top oxygen and make another bond there. Right, so that gives 0 for the left hand, 0 for the top one, minus 1 for the right hand one, and let's take a look at the chlorine now. All right, so now the chlorine has 7 minus 7, so a 0 formal charge. Right, so to finish off my drawing, technically I should have brackets and a symbol showing the charge of the ion. All right, so this is our completed Lewis drawing for the chlorate ion. Okay, it has the lowest possible set of formal charges that maintains the charge of the ion. We show where the charge is, and everything has at least an octet. Chlorine is allowed to break the octet rule because it's not in period 2. Anything period 3 and lower is allowed to have more. Okay, so this is an example of expanded octet. Right, now this also gives us a chance to look at resonance. Okay, so resonance, for purposes of our Lewis drawings, is when you have more than one correct Lewis drawing. Okay, so right now I have the double bonds on the top oxygen and the left-hand oxygen. I can also have, so let's draw that real quick. I can also move the double bonds in different positions and have still correct Lewis drawings. Or let's try a different version actually. Let's put them on the sides. Okay, both of those drawings are correct. And so what it means is that with, multiple double bonds and a single bond, those bonds are actually sharing the total of those electrons. So sometimes the double bond may seem like it's left to right, sometimes it's top to bottom, sometimes it's left and right. But we have correct Lewis structures that have different arrangements of the double bonds. The reality here is that each of those oxygens is sharing the extra couple of electrons. Okay, so instead of 2 double bonds and a single bond, the reality is that I have 3 1 1/3, 1 2/3 bonds, something like that. Okay, but when we're drawing Lewis structures, we stick to showing whole structures, no dotted lines. So let's move on to our next exception to the octet rule. right? So sticking with exceptions, and this exception is a deficient electron count. Okay, electron deficient species, right? And the prime suspect for that one is boron, right? So boron typically only makes 3 bonds. Okay, in other words, 6 electrons shared. Right, boron is perfectly happy being lower than the octet rule. Right, so a common example of that would be boron trichloride. Has 24 valence, and the drawing comes out like so. Right now, if we disregard the octet rule and take a look at formal charges, we'll find that everything in here has a formal charge of 0. Okay, we're perfectly happy as we are. So avoid trying to make extra bonds with one of the chlorines in order to force boron to have 8. Boron is perfectly happy with 6 electrons around it. Now, an interesting way that this plays out is in a molecule called boron hexahydride, diboron hexahydride, so B2H6. And what we get is an interesting sharing of bonds. Because boron really doesn't want to have 8, it would prefer to have 6. What it does is it has partial bonds with those extra hydrogens. So each of those is 1/2 of a bond. Right, so we get a total of 3 bonds for each boron. Right, so boron is an electron deficient species. That is one exception to the octet rule. That's our second exception to the octet rule. So we're going to go ahead and pause this video right here. We'll come back on our third video talking about our next exception to the octet.